there is a different scenario to set this one. Number 19 was the oddball of the 5 from last night. If you got to it and you've kind of figured out some of it, awesome. If not, it's not the end of the world. Because like I was saying, I was going to start with this part here today. So on 19, what I want you guys to notice is that they're asking you to prove that a definition occurred as opposed to a segment or something along those lines. So as you go through it, we're going to do this proof and walk through it just like we would normally. In the back of our minds, we have to think about, well, what does it mean to bisect a segment? What occurs when you bisect a segment? What happens when you bisect a segment? Make not two angles, or segments. You get two congruent segments, correct? So if in the very end here, I want to say something about KQ bisecting the segment JP. I have to be able to say that JP was bisected. If JP gets bisected, what would be the two segments that have to be congruent to each other? That means we have to show that somehow we'd have to show that JM was congruent to MP. So basically, if we're able to show that happens, then we know that it was bisected. So what we're doing here is we're kind of working backwards from one of the progressions. You really start thinking about it. So we start the proof just like you would every single other proof. You draw it, we write down the given. And again, you have to be able to mark your diagrams. You have to be able to work with the diagrams in order to figure out what in the world is going on. So you're given parallels. When we're given parallel, remember, we like to draw the parallel to follow where the angles occur. So if I have JK is parallel to QP, if I know that happens, where that transversal changes directions with parallel is always going to be where the angles themselves are congruent. I know here and here have to be congruent. So I fill that in. I can use one letter here because it's the only vertex that it has that. So I can say angle K is congruent to angle Q. Two parallel lines cut by a transversal, alternate interior angles. All right. Again, you could do something, you can do another thing here if you want. Actually, I'm sorry, there's two different things you can do. In this picture, does everybody agree that there are vertical angles with the vertex of M? Okay. We could say something about those because we see that. Or we could say, is JP also a transversal? I could also trace that one and do another set of alternate interior angles. Does it matter which one I choose? It doesn't. It really doesn't. Okay. So, do you guys want to do vertical angles then? All right. So if we do vertical angles, everybody agrees that we see that right now. So if I say angle K, M, MJ, what would have to be the corresponding correct lettering to KMJ? QMP, yeah. Remember, you're following the tick marks. Vertical angles congruent. All right. Is it okay that we went out of sequence from our given statement? Yeah. We just remembered that we had another set of angles. We saw it, we wrote it down, and went for it. So what's the next thing we would write up for our proof here? The other given, JK and PQ. JK, PQ. Okay. Do you have two triangles that are congruent to each other? We do. By what method? Very good. This is an angle-angle side. The reason why it's angle, angle, side, not angle, side, angle is what? The side is after the two angles. Okay? Very, very straightforward. That's why it's visual. That's why we draw diagrams. That's why you fill in blanks so you can see which of the possible 5 that you have. Now, we just spent an extra 30 seconds on making sure that our lettering matched correctly for the vertical angles. If I change that angle symbol into a triangle symbol, will those letters be okay? Yeah, that's the kind of the tip I want you guys to remember. If you spend time rewriting angles to match, use those same angles as the letters for the triangles. Or, which we'll see here in a little while, if you're ever given angles that are congruent, you have to show what triangles are, use the given angle letters as the triangle letters. It doesn't hurt. You're using something you already know that works. So if we say that, we can go with triangle KMJ, congruent to triangle QMP. And we said a second ago was angle, angle, side. Now we go back and saying that, hey, in order for us to show that something was bisected, that meant that somewhere in there we had to have congruent segments. Well, once you get, and this is the new part for you guys who were gone yesterday, once you have triangles that are congruent, then you know that all of their corresponding parts have to be congruent. So we look at it and say, all right, we have triangle KMJ. KMJ. We've got that triangle here. And we have triangle QMP, just following the letters. We have that one there. There's correspondence between everything. We know that we have 2 angles already that are congruent to each other. We have 1 set of segments that are congruent to each other. If I follow the lettering, and I can say MJ is congruent to MP. The letterings correspond. Or I could have said JM, PM. Either way, it would have been okay because corresponding parts, congruent triangles, are congruent. That's that new little step you have to decide on. It's called cpctc. Corresponding parts of congruent triangles are congruent. You are allowed to use that to show other things that are congruent only after you have triangles that are congruent. And that's the part. Now that you have those segments that are equal or congruent to each other, we can say then that this happened. KQ bisects JP as the definition of a segment bisect. Okay. What I want you guys to think about here is that when we do this style of proof where you have to prove a definition, usually the definitions we're talking about proving, segment bisector, midpoint, or an angle bisector. We normally don't change from those 3 because then it gets to be too messy. We know that we have a segment bisector, that means 2 segments have to be congruent to each other. If we have a midpoint, we know that 2 segments have to be congruent to each other. If I have an angle bisector, we know that 2 angles have to be congruent to each other. That's what you're looking to be able to do. Okay? It's not pushing over too much crazy, just the right amount of crazy. Okay. What's that? Oh, I already grabbed it. You didn't have to do that last one. I was going to use that as our notes for us to start out today. That is one of those first 4. So let's try another one. Yeah, that's fine. Thank you. So let's try another one. B is a midpoint of AD, and angle E is congruent to angle C. We're going to prove that B is a midpoint of EC. Excuse me. You guys good? I'm gonna go ahead and shrink this down and move it over a little bit so I have a bit more room to write. You all know my handwriting's awesome. Oops. Didn't want to clone it. Try that again. There we go. All right. I just wanted to move it off the side a little bit so I have a little bit more room to write on this marker. So, when you have a proof, what's the very first thing you're always going to do? Given. All right. What's your first given? B is the midpoint of AD. Hey, that sounds like there's a progression involved. According to your sheet, B is midpoint AD. That means, according to my sheet, what do I say next? Like it. What should I do to my diagram? Good. All right. So I go right to my diagram. I mark down what you guys just recited in unison, which is really weird. AB is congruent to BD. Because my reason is, it's like you guys know what you're doing sometimes. Sometimes. All right. Have I fully utilized that first given statement? Yes. What do I do next? Next given, angle E. Check marks. Good, 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 good. This is another example of having to do what next? Vertical angles. Okay. So now that we have our next, excuse me, what I want you guys to think about, and a lot of you are picking up on it right away. This is that bow tie looking one, which means you're going to have vertical angles. If you don't remember that, go back and forth of what your pictures look like on your progression sheet about ways to prove. Right now we have a side and an angle marked up, which means it's either going to be side, angle, side, angle, 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 side. I can throw out hypotenuse leg because there's no right angle. So it's going to be one of these three. So that's why we look, okay, is there anything in this diagram that can get me another segment? Is there anything in this diagram that can get me another angle? And that's where most of you guys are saying, oh, there's vertical angles. Okay. Which is fine. If it takes a second to figure out, whatever. What we have plenty of time. I mark it. If I say angle E, B, A, C, B, D. Okay, good. You have to use the correct lettering. You use the correct lettering to make sure it matches. And we do that, like you guys just said, it's going to be angle CBD. Because vertical angles are congruent. What letters do you think I would say to use now for the triangles? Exactly, the ones I just used. We just spent 2 minutes on making sure that we wrote up the letters in the correct manner. We use them for triangle symbols. Remember, you have to have symbols. And this one was angle, angle, side. Very good. Now, think about what you have to prove. If you're going to prove that you have a midpoint, what would have to have occurred before having a midpoint? Say it, you got it. You had it. The two segments. Now, if I want to be a midpoint on EC, what would have to be my two segments? EB and BC. So I read it. EB, here at BC. What's that? Segment-wise, I don't care. It's okay, especially with midpoints, because you're just going halfway through that one. Angles, yes. Guys, this comes up a lot. It's not the end of the world with segments, especially when you're talking about midpoint stuff. If the letters are flip-flopped, it's okay. It really, really, really matters with angles, and it really, really matters with triangles. So whenever you have 3 letters, make sure everything matches. So now, because corresponding parts are congruent triangles, that happens because the definition of a B is the midpoint of EC because the definition of a. Basically, we're using it backwards from what we did before. Going backwards. I want you to do this one. I am really good at drawing. Remember, ladies and gentlemen, as you're going through these styles of problems, as you're going through these things, a lot of times, all you can do is literally mark the diagram, because there's nothing else left to do. So as I go through this, CY, congruent, XY. Give it. Mark it. You go to the next one. Angle. WYZ congruent to angle WYX, which means you have to find those angles. Follow the vertices. Follow the letters. W, Y, Z. Oh, there's one. W, Y, X. Oh, there's the other. There it is. And again, you've got to reflex it. One of the things I've been noticing also, when you have other things that are congruent, you can't use the same number of tick marks. One set of segments gets 1 tick mark, the next set of segments gets 2 tick marks. One set of angles gets 1 tick mark, the next set of angles would get 2 tick marks, and so on and so on and so on. Now, according to that diagram, do you have triangles that are congruent? Yeah, because of what? Side angle side. And this is another one of those examples where I'm going to reuse the lettering always already given to me with angles, because those letters match when you put triangle symbols in front. And this was side, angle, side. This problem is asking you to show that YW, sorry, I misspoke. YW bisects angle ZWX. You were just saying Z. I have to say that first. Why are those two parts congruent? You're right, those are the right angles, but why are they congruent? Nope. Yep, corresponding parts, congruent triangles are congruent. Now, guys, remember, only 5 possible ways to show triangles are congruent, and cpctc is not one of the ways to prove triangles congruent. What else is not one of the ways to prove triangles congruent? Yes, ma'am. I'm sorry we were talking over you. Oh, I don't know. I don't know. I just. Thank you. I had no idea. Sorry about that. But you know why? I bet you know why I did that by mistake. I think I was looking at what letterings there was matching up with the angle, and I saw I was going to have to go what matched up with the Z, and I wrote Z matched with the X. I just actually wrote it down. Now, here's the thing. Let's say you did something like that on a quiz or a test, and if you remember, see if I had it still here. Let's say I accidentally put the Z there because I thought I was saying something out loud, and I put XWY. Maybe I just accidentally thought I was making an angle symbol and I made it into a Z because I'm crack apparently. I don't know. But would I mark you wrong for that? I wouldn't, because you know why? These letters match. I would just do this and just say here. You know, you just made an extra symbol there just by mistake. You overlooked it. Something like that doesn't necessarily mean you have no clue what you're doing. Something like that still says that you've matched up the other letters with the X, W, and Y because you marked your diagram. Especially if you marked your diagram, I know you knew what the lettering was. You just made an extra symbol by mistake. This is very, very important that you guys write down what you're going to be doing via the diagram as you're writing it down in words. And I think we've mentioned this when we get to second semester when we do some right triangle trig stuff, sine, cosine, tangent. You have to write down what you're doing before you press the buttons in the calculator. Because if you just press buttons, you can accidentally hit 3 instead of a 5. Or hit sine instead of cosine. And get completely wrong answers. But if you write down the buttons you're going to press before you press them, we know that you're, for lack of better terms, not having dumb thumbs. Right? It's just it's a simple thing. So now we've got the angles that are correct, which therefore means that it was bisected, so then you can say WY, YW, bisects, angle, so I can use just 3 letters this time, ZWX. And this was because the definition. Okay. We got a couple more of this style for you, as well as some straight, regular old cpctc. We have a couple of minutes here. No problem. We have a couple minutes here, so why don't we start on number 4. Let's start on number 4 and see how you go without. One other thing with this, guys, just because there are so many lines does not mean that you have to have that many lines or that many statements and reasons. You may need more, you may need less. It just goes no problem. It was just that those were written out in such a long time. They just didn't fix it. Okay. So start on number 4. We'll get a good start on. We got a couple of minutes. We should be able to make sure that we did that correct before we get out of here. 4 is on the back, yes. Here. So we start this one. Wasn't right. I'll make sure we get through on this one here. All right. So ladies and gentlemen, as we start this one through, givens, mark it. Next one. Sorry, I break down givens. Market, angle BCA, DCA. Follow the letters. What's left? Well, how about the triangles though? Reflex. AC, can I write CA is congruent to CA? Does it matter? Sorry, I'm boring you. Do you have triangles now? Yes. Do we have triangles because of what? I don't see cpctc over here. We have side angle side, so our triangles then, I'm just going to reuse my lettering up here that was given to me, triangle BCA. Or if I wrote it out a different way, I just have to make sure it matches. Now, in order to show that AC bisected angle BAD, well, we have to figure out where do those angles occur. Well, here's AC, and it's bisecting the angle up here. So that means I have to talk about these two angles here and here. BAC has to be congruent to angle DAC because of corresponding parts in congruent triangles are congruent, which then lastly allows you to do what? The proof, right? AC bisects angle BAD. What's my reason? Yeah, definition of angle bisecting. And to be honest, when you go into this one second here, if you have to prove a definition, guess what your reason's always going to be? The definition of whatever you have to prove. You should never get that wrong. Even if you get the rest of it wrong, that one should be straightforward. Sorry, I can see through it. Works for me. Nice enough. So, like I said, finish one out for tonight. We'll go through a couple of leftovers tomorrow. We'll deal with isosceles, equilateral triangles tomorrow. There's usually like one or two quick, very simple progressions thrown in there. We don't normally do a lot of proof with it. The proof that we do with equilateral and isosceles tend to go with the algebra. So if you haven't been bringing your calculator a lot, make sure you have a calculator tomorrow. We got some more algebra stuff to go through. Yes, ma'am.